Hello there, this is Alana Tuckey, and I received this question about 12-2 number 17. I'm going to show you how to do it with StatCrunch. Let's see how it goes. All right, so I'm going to click the View an Example part. All right, so we have a survey of 36 randomly selected students who dropped a course was conducted at a college. The following results were collected. So you have the male, personal, female for work, male for personal, male for personal, male for personal, male for the course, didn't like the course, male for the course, etc. So we have all these different reasons. So the first thing we want to do is create a contingency table. Now they make it show up like this, all pretty and perfect, but you might be thinking, ooh, how do I do that so fast? Well, there are a couple different ways. So let me click on the data set, and I can open it in StatCrunch, or I could copy it to a clipboard. Either way should work. So here it is in StatCrunch, and you can see all the different reasons, right? Male for personal, female for work, and so on. So let me go to Stat, and let me see. Tables, there it is. And then I'm going to make a contingency table with data, because I have data in this problem. Now my row variable is, I think, gender. Let me see. Let me go back. Where is it? Yeah, gender, right? Male, female. So it doesn't really matter that much, but I'm going to do it the way they did it. So I'll pick the gender to be the row variable and the column variable to be the reason they left. Now down here we have a whole bunch of different options, different ideas of things we can do, like do we want to know the row percent, the column percent, the percent of total, the expected count, if you want your expected values, things like that. So you could have it find all sorts of things if you were interested or not. And then down here you can see you can do a chi-square test for independence and so on. Like let's say I want to do the expected count and the chi-square test for independence. And then we don't need any confidence intervals for this. And I'll click compute and see what shows up. Let me make that bigger. So you can see there's 5, 4, 8 for female and 5, 11, 3 for male right there. And then the expected values are the ones in the parentheses. So you expected 4.72 females, you expected 7.08 females, and so on. And down here you have your test statistic and your p-value. All right, so let's see if that matches up with what they do. Come here. All right, so female was 5, 4, 8, male's 5, 11, 3, excuse me. And then test whether it's independent, which is at the 0.1 level of significance. So they've had the expected counts that they need to find. So they're doing all of that. But the StatCrunch did that for us. See the 5.278, the 4.722. That's right here. 5.28, 4.72 right there. Right? So what they're doing is they're multiplying, let's say for the 4.72, they're multiplying 17 times 10 and dividing by 36. For the 7.08 here, the computer's multiplying 17 times 15 and dividing by 36. All right, so that's that. And then your p-value is 0.066. See right down there? Which is what we thought it was. Now let's see here if I go back. 0.066 right there. There's your p-value. And there's your test statistic right there. Okay, so then construct a conditional distribution of a reason to drop by gender. Okay, well, let's see if I go back. I can go to options and I can go to edit. And I can say I want, let's see here. Well, if you want the by gender, let's see here, that'd be looking at the row, right? So you're saying, okay, I want it by gender, so I want to take 5 and divide it by 19. I want 11 and divide it by 19, and 3 and divide it by 19. So I don't know if that options window kind of disappeared. Yes, it did. All right, so edit, and then I want row percent right here. So I want to display that as well as the expected count, right? So I click row percent and click compute. There. Now it's modified it slightly. So it's giving me 29% out of the total, 23%, and so on. And my rows add up to 100%. See, because by the end I've got 17 out of 17. So let's see if that matches what they give. So it says male is 26.32, male in course. So let's go back. Yep, 0.263. See right there? And then 0.579 and so on. And then one imagines you could make a bar chart of this, because what you would do is you could compare these two course percentages against each other, and then these two personal percentages against each other, and so on. And that's it. So we have the conditional distribution here. And again, if you want to go back and get the other one, you'd have to get expected count. Oops, I could select all of them. There we go. That'd be interesting. Here. Then I've got everything in the kitchen sink, right? Okay, so if you do that, then it says you've got the count, which is up at the top. You got your row percent, that's your conditional distribution, that's the second one for gender. Then you got your column percent, that's your conditional distribution by course, right? Or by personal, by the column. And the very, very bottom is your expected count. So that would work. I just held shift to do that. And don't forget your p-value right down here. So you know you're going to not reject the null. Or wait, maybe you are. What was your alpha? Alpha was 0.10, I think, maybe. 0.10. So you are going to reject the null hypothesis in this instance because 0.06 is less than that. Now, if you're on a calculator, you can do the same problem. You'll have to figure out the tallying part by yourself a little bit. But you can make a matrix. So you go second matrix. Oops, not second inverse. Second matrix. There we go. And you'd edit. So go to the right to edit. Pick number 1. And you'd say you have a 2 by 3 column. And then you have to type in the values for your observed values. So hold on, let me go back to, so that'd be the 5, the 4, the 8, and so on. You'd have to count those up yourself or something. So 5, 4, enter, 8, enter, and then what was it for male? 5, 11, and 3. So pull that back. 5, enter, 11, enter, 3, enter. All right, so there's your observed values. So that's done with matrix A. And then you go second matrix again, and now you want to edit matrix B. So make it 2 by 3. And then here it's going to get a little interesting. You'll have to do the calculations. So remember, let me make this smaller so we can see what we're doing here. To find that first row, what you do is you take 17 times 10, the totals for the column and the row, and divide it by the grand total, 36. So I would say 17 times 10 divided by 36. Enter. And then it finds it, 4.72, just like it does up here, 4.72. And then I would do it again, 17 times, and the next column is 15 divided by 36. 17 times 8 divided by 36. So there's all the female ones done. Then 19 times 10 divided by 36, 19 times 15 divided by 36, and 19 times 11 divided by 36. There we go. We got them all. I don't know what I'm doing there. So delete that. Okay, so now let me quit and get out of here. Clear that. So if you want to run an independence test, you go to second, oh no, not second, stat, to the right to tests. Oh, I can make this bigger now. Hold on. To the right to tests, and then at the bottom somewhere, there's a chi-square test right there. And so we observed in matrix A, second A, right there. So to get that name there, you have to second matrix, pick names, see how you're on names right now, and you take number 1, and there it is, right? And then expected was in matrix B, blue is fine, we're not drawing this anyway, and then calculate. And there you go. So 0.066, just to like the StatCrunch found. All right, we're all done with that problem. I hope that helps.